And under decimals today, we look at multiplying them. Did we multiply decimals last year? Does anybody remember the rule for multiplying decimals? No? Perfect. So then you'll learn something today. Multiplying decimals. First things first, please understand this. Okay, you don't, with a capital D-O-N-T, have to line them up. Matter of fact, they might at sometimes happen to line up, but you don't have to line them up. Okay, make sure you put that in your notes because I see too many people that. Let's do an example problem. Let's say you have 5 times 0.8. 5 times 0.8. 5 times 8 tenths. Step number 1, children, is a simple one. You simply multiply like normal. Which means this is like multiplying 5 times 8. I get 40. And then comes the really special thing we need to do. Step number 2, because 40 is not the answer. The digits are 4 and 0. The question is, where does the decimal go? And if you remember this from previous years, what you need to do, and this is what multiplying decimals is all about, you need to count decimal places. In both numbers, in both hashtags, which means there is no decimal, there are no decimals, there is no digits to the right of the decimal here, that's a big fat 0. This one has 1. So in your answer, which is step number 3, you need to start at the right and move the decimal back that many places. Run out of room, many places. Which means, since I just had a grand total of 1 decimal place, I start with the decimal here, come back 1 place, and my answer is 4.0 or 4 if you like. But however many digits are to the right of the decimal in these two numbers is going to be how many digits are to the right of the decimal in your answer. So if I change this problem to say what would be 0.5 times 0.8, now in that case it just so happened that the decimals lined up. Doesn't mean that's where your decimal is going to go in your answer. You still multiply 5 times 8 together, you still get 40. But how many decimal places will there be? There's 1 in this one, and there's 1 in that one for 2. So you go back from right to left 2 places. So your answer is 0.40. Or 0.4, whatever you want. How that works. Does that ring a bell? Yeah. At all?
Yes.
So let's say you've got 0.25 times 0.5. Writing it up and down, 0.25 times 0.5. Notice the decimals don't line up and they don't have to. You don't worry about that. But right away you should say how many decimal places are there going to be in the answer? How many digits to the right of the decimal in my answer is there going to be? Alex?
3.
3, because there's 2 on the top and 1 on the bottom. So after I do my multiplication, I'm going to count back 3 places. 5 times 5 is 25. Carry the 2. 10 plus 2 is 12. Okay. 2 places there. one place there for 3, so I go 1, 2, 3 places, so it's 0.125. As opposed to what would I get if I had this just times 5 and not 0.5? You're going to get the same digits. You're still going to get a 1, a 2, and a 5. It's just that the decimal is going to be in a different place. Where will the decimal place be in this one? Come on.
Between the 1 and the 2.
Yep, come back 2 places, and it's between the 1 and the 2, because there's 2 places there. Let's try another one. How about this? This gets exciting. What would be the answer to this? 1.2 squared. What do you suppose the answer to that would be? Actually, you probably could tell me almost. 1.2 times 1.2, that's what squared means. What is 12 times 12, anybody? Nobody know? Anybody else know? I get a 1, a 4, and a 4. Where my decimal going to go in that 144? Where, pray tell, Kaylin, does that decimal go?
Between the 1 and the 2.
Right, because there's 1 decimal place here, 1 decimal place there, so I come back 2 for a grand total of that. If I have $1 and 20, if 8 people give me $1.25, how much money will I have? If we did the math, 8 people give me $1.25, well, you know it's got to be more than $8, but 40, 16, 20, 2, 10. How many places do I have to move the decimal? Brooke Calla?
2.
I come back 2 places and it goes right there. Most people get mixed up because they start moving the decimal from the left to the right, or they do something goofy like that. It always starts at the end and comes back. 2 decimals after the, 2 digits after the decimal, 2 digits after the decimal there. Is there anything else funny and or special? Oh, here's one that always gets trouble. I remember this problem. There is children, a little cheer that your parents may be too young to know, but maybe when I was 20 years ago they weren't. There's a cheer that says 2 bits, 6 bits, 2 bits, 4 bits, 6 bits. You know the rest of it? All right. I want you to go home and say that to your parents. Go 2 bits, 4 bits, 6 bits, and see if they finish with $1. Question number 3 on today's assignment says this. A bit, it's an old term for money, is 1/8 of $1. So hence the song would go 2 bits, 4 bits, 6 bits. The next one, instead of saying 8 bits, which is $1, because there's 8 and 1 is $1. The book asks you this, how much is 6 bits? If 1 bit is 1/8 of $1, how much is 6 bits? Cabran says
1/6.
6. Well, I want to know how many cents 8 bits is, or 6 bits is. Now here, let's look at it like this. You have, if 1 bit is 1/8, then 6 bits is 1, 2, 3, 4, 5. 6 bits is how many 8s?
6
And 6 eighths is what?
3/4.
And what is 3/4 of $1?
75 cents.
75 cents. 2 bits is a quarter. 4 bits is a half $1. Back then, you could buy something with a bit. I don't know if there was ever a coin for a bit, but Laura, what is your part of your assignment?